Hi! It's a pleasant day and happy learning to each and everyone. To formally start, I would like to introduce myself first. I am Ivy Sibete, a second-year student taking a Bachelor of Secondary Education major in Filipino. And it's a great honor and pleasure to be in on your screen today and to discuss this important topic with you together with my partner, Ms. Eprilyn D. Calago. We would like to discuss with you to Chapter 10 of this lesson, which is the utilization of assessment data. In this chapter, we will get to know the test results of students' performance that can aid in making informed decisions to improve curriculum and instruction of the teachers. We shall look into the different types of test scores and interpret this scores as well. And lastly, this chapter will also present test score interpretations using norm criterion reference interpretations. So, moving on, here are the intended learning outcome as we continue learning this topic. So, at the end of this chapter, students are expected to provide meaning to test results using norm reference and criterion reference interpretation. Now, let's proceed to the types of test scores. Here are the types of test scores. The types of test scores, there is the number 1, row and percentage scores. Number 2, the percentile ranks. Number 3, standard scores, and associated with the standard scores are the following: the Z-score, T-scores, star 9s, and normal curve equivalent and developmental scores. So, later on, we will get to know this type of test scores. So, according to Harris in 2003, results of tests are in the form of scores, and this may be row scores, percentile rank, Z-scores, T-scores, star 9s or level, category or proficiency scores. The first type of test scores is the row and percentage score. So what is this row and percentage scores? Row scores are obtained by simply counting the number of correct responses in a test following scoring direction. For example, if there are 50 items in the math test and the students got 30 correct responses in the test, the row score is 30 over 50. As you can see on the screen, the math test that the student got is 30 correct responses over 50. Again, to determine the row score, it can be just simply obtained by counting the number of correct responses in a test. So, as you can see, the row score in the math test the student obtained is 30 over 50. That is the row score. On the other hand, to obtain the percentage score, we just have to divide the correct responses over the number of items in a test. So if the student got 30 correct responses out of 50, 30 divided by 50 is 0.6, and multiplied by 100 is equals to 60%. So the percentage score is 60. As a result, the student was able to answer 60% of the items. Now, what is a percentile rank? A percentile rank gives the percent of scores that are at or below a row or standard score. It is used to rank students in reference sample. So, nothing that percentage score and percentile rank is different from each other. So, in percentile rank, we can determine the rank of the students based on his or her score and compare to the rank to other students who also take the test. So, in percentile rank, for example, if the student got 35 and 35 is equivalent to 84th percentile, so let's say there are 200 students who also took the test. How can we get the rank? Here is the solution. 84 divided by 100 is equals to 0.84 times 200, which is the number of students who took the exam. The percentile rank is equals to 168. what does it mean? What does it mean? The interpretation is that if there were 200 students who took the test, a percentile rank of 84 indicates that the student is higher than 168 students. Now, let's proceed to number 3, standard scores. So, what is standard scores? It is difficult to use raw scores when making comparison between groups or different tests, considering that the tests have different levels of difficulty. An example of this is a test from Math and a Filipino subject. Do you agree that these two subjects have different levels of difficulty? Yes, it is. So let's say if the student got 40 over 50 in Filipino subject, while in mathematics the students got 25 over 50. We can't compare these raw scores because there are different, and as you may have noticed, a student can have different strengths and capacity on different field. So how can we determine and make comparison of these scores? We can determine and make comparison of these scores by using derived scores. Now, what is derived scores? So, the derived scores are a family of scores that allow us to make comparisons between test scores, just like in the previous slide, the two different scores from different subjects, we can make a comparison into that. So first, let us define the two types of derived scores. So there are two different types of derived scores, which are the scores of relative standing, which include percentile, standard scores, and stanines, while the other is the developmental scores, which are scores that have been transformed from raw scores and reflect the average performance at age and grade levels. There are different types of scores of relative standing. First, we have z-scores, second, t-score, and lastly, we have stanine. But before we proceed to the next slide, we have an example of a normal curve. So, as you can see, this is a normal distribution of standard deviations. Here we have our mean, which is the 0 in the middle. In the right side, we can see the positive value, and in the left side, we can see the negative value. Next, we can see the cumulative percentages, the percentiles, the z-scores, t-scores, and the standard 9, that also known as stanines, and then lastly, percentage in stanine. Now, we have z-score. What is z-score? Z-score gives the number of standard deviations of a test score above or below the mean. Here, we can see the formula of the z-score. Z is equals to our raw score minus the mean, then divided by to our standard deviation. Here we have a chart. A negative z-score means it is below the average. And then a positive z value means it is above the average. So, we have an example of a normal curve. The mean here is 0. So, if we got a z-score below the mean, it means it is negative, and likewise, if we get a positive z-score, it means it is above the mean. Now, let's move on to algorithm step for z-score. This is a step on how we get the z-score. First, we have to subtract the x or z-score to our mean, then divide the total score to the standard deviation. So here we have an example. A score of 12 and a 20-item science test with an arithmetic average of 15 and standard deviation of 2. The given here is our raw score is 12, our mean is 15, and our standard deviation is 2. So let's use the formula of z-score here. Z is equals to raw score, subtract to our mean, then divided by to our standard deviation, which is 2. So 12 minus 15 is equals to negative 3. Then divided into 2, that's why we get the negative 1.5. So, to further learn about the standard score, my partner Aprilyn D. Calago will discuss the T-score, STAR9s, normal curve equivalent, and developmental scores. So that would be all for my part, and thank you for listening.
Good day everyone, I am Aprilyn D. Calago, the second reporter, and I will continue the discussion which is all about T-score, STAR9, normal curve equivalent or NCE, and developmental scores. And now, let's discuss the T-score. A T-score scale. The mean is set to 50 instead of 0, and the standard deviation is 10. To transform a z-score to a t-score, we multiply the z-scores by 10 and add 50. Before we get the t-score, we must get first the z-score. And as what you can see in the screen, this is the formula of t-score. T equals z-score times 10 plus the mean, which is 50. Earlier, we get the z-score, so we will use it to get the t-score. T is equals to 10 multiplied to negative 1.5 plus our mean, which is 50. 10 times negative 1.5 equals negative 15 plus our mean. Negative 15 plus 50 equals to 35. And 35 pertains the row score of 12. In the given situation, in the z-score, the value there is negative, so we can convert it by getting the t-score. In that way, we can easily understand that it can easily perceive that 35 is the row score of 12. Now, let's proceed to STAR9. STAR9, short for Standard 9. It is a method of scaling scores on a 9-point scale. It is a 9-point grading scale ranging 1 to 9. So unlike t-score and z-score, the mean of STAR9 have 5 and standard deviation is 2. And as you can see in the screen, that is the formula of STAR9. Then, letter D, normal curve equivalent or NCE. This is similar to percentile ranks, and it is a normalized standard score within the range of 1 to 99. It has a mean of 50 and standard deviation of 21.6. Example, an NCE of 30 in reading is twice as far from the mean compared to an NCE of 40 in mathematics. The student's score in mathematics was 10 points higher than in reading, but both are still below the average score of 50. E. Developmental scores. It is a grade equivalent or GE describes a learner's developmental growth, and it defines a person's first performance in terms of the average of particular group's performance. Example, age equivalence and grade equivalence. This is the types of text scores interpretations. And the first one is non-reference interpretations. The term norm originated from the Latin word norma, which means precept or rule. It is an explanation of a learner's performance in comparison with other learners of the same age and or grade. Norm reference evaluation determine the learner's place or rank. For example, the child placed 8 in reading class. This is one of the examples of a norm reference description, which is they have ranking and who got the highest score and the lowest. Before the average, this example determined the student's rank or place. Assessment instruments that leads itself to this kind of interpretation. Included this standardized aptitude and achievement test. Teacher-made survey test, interest inventory, and adjustment inventories. Nitko and Brocard stated 5 guidelines with interpreting norm reference test scores. The first one is detect any unexpected pattern of scores. This means that be on the lookout of unusual or specially extreme scores. And the second one is determine the reasons for score patterns. There is a reason in performing in one or more subject of the students. Third, do not expect surprises for every student. The teacher must know how each student is performing on his or her class. The fourth, small differences in subset scores should be viewed as chance fluctuations. And test scores may or may not be statistically significant to the call of instrumental intervention. And the fifth, or the last one, use information from various assessments and observations to explain performance on other assessment. It will not be shocking to learn that students with poor writing skills on English or Filipino would obtain a low score in essays. That is part of the test. And B, criterion reference interpretations. The word criterion came from Greek word criterion, means standard. Provide meaning to test scores by describing what the learner can and cannot do in light of a standard. For example, taking an entrance test or entrance exam in a university, we need to get what the university standard has set. So in the classroom reference example, we have an activity which is writing an essay. And writing an essay, we have a standard. There is a rubrics or a criteria that we must follow or we need to get so that the teacher can interpret it, or if the student really follow the standard they set. So criterion reference included percentage, speed of performance, quality rating, and precision of performance. It is used in diagnosing students' needs and monitoring their progress. It is like an program evaluation. When interpreting a standardized test score, there is a assumption of normality in distribution of test scores. This is not necessary criterion reference. Just like my example earlier, that we need to test or we need to set standard and get that standards so that we can recognize what we can do and what we cannot do. Summary: assessment data provide a means to look at students' performance to offer evidence about student learning in the curriculum, provide information about program strengths and weaknesses, and guide the decision making. In relation to this, there are different types of test scores that can determine the performance of the students, such as row and percentage scores, percentile rank, standard scores, z-scores, t-scores, stan 9, normal curve equivalent, and developmental scores. Thank you and happy learning!